Hello students, this is topic 4 and in this lecture we will be studying about terms which are associated with spherical mirrors. Unless and until you know this term, you won't be able to draw the ray diagrams or do the numericals of this chapter. So this is a very important part and please see this. Here is a diagram which I have already drawn here and you can see a circle which is drawn here, right? So this is a plane, this is drawn on a 2D picture. So, but actually this is a sphere. If you consider this to be a sphere, a hollow sphere, and then you cut out a portion from the hollow sphere, just like a ball that you play with, they are hollow in structure. So, if you cut one particular portion of that particular ball, not from the center, but from a side, then that particular portion when you take them out, so this is the cutout portion now. See, this is the cutout portion. Right? If you cut that section and then you take it out, so this is how it will look like. So this is now a simple piece of glass. Now to convert it into mirror, the side which you want the reflecting portion, suppose I want this piece of glass to make it a concave mirror. I want it to make a concave mirror from this spherical piece of glass. Then the back side of it will be painted. It will be coated with the solution of silver nitrate and the same cutout portion like this one, if I want to make it convex, so what do? I paint this particular part, that is the cave portion part, with the silver nitrate solution, and this particular portion becomes the reflecting surface. So this is how the concave mirror and the convex mirror are formed. Is this clear? Now we start with the first topic, that is the first point, which is the first term associated with this, that is aperture. In this figure, the line that you can see AB is written here, point A and point B. So this line is known as aperture. Now what does it do? Aperture is actually telling us about the size of the mirror. Now you can have mirrors of various size. Suppose you have a mirror like this. Okay, I am not drawing the back side of the mirror. A mirror of this size, a mirror of this size. So we have different sizes of mirror, you can see here. If this is a concave mirror, we are just taking an example of it. So you can see that there are different sizes of mirror which are available in the market. So how do we come to know what is the size of the mirror? From where do we measure them? So we measure the tip of the mirror to the another tip of the mirror. This particular line, this is telling us the size of the mirror. So this particular line is known as aperture. So in the definition, while writing the definition, since this is in the cutout area, this is the longest line it can have, and the longest line in any particular curve area is known as what? Diameter. You must have read it in the mathematics. So diameter of the spherical surface is known as aperture. This is how that we write the definition. Definition you will be able to see that is the longest length. So this is clear, I think. Longest line is always the diameter. Diameter word is used in the definition. Don't get confused with the type of the diagram which is drawn here. We are not talking about the diameter of the sphere over here. We are talking about the longest line of this cutout area. Now when you cut this area out of the sphere, this is not the part of the sphere right now. This has come out from the sphere. And if we want to draw here the longest line over here, where it will be? From one point to the other point. So this longest line now becomes the diameter of this spherical surface. That's why the definition is written, the diameter of the spherical mirror is known as aperture. Okay, go through it. In your NCERT book this is written already, and in the notes also this has been provided. The next term is the pole. Pole is represented by capital P, and this is the center part of the mirror, that is known as pole. The next term is center of curvature. Center of curvature. So as the name tells here, this is represented by capital C. You can see it in the diagram. This is the center of curvature. Now what is center of curvature? When this particular spherical mirror was cut out from particular sphere, so this was cut out from this sphere, right? This sphere has its center. That center is known as the center of curvature. So the center of the sphere from which the spherical mirror is been made, that is known as center of curvature of the spherical mirror. This is that particular point from which if any ray is been passed, then they do not deviate anywhere. We will come to that point later. The next one is the principal axis. This is a very important point, and make sure you write the spelling properly. It's PAL, not PLE. Most of these students, they does an error in this particular part. So it's principal axis. Principal axis is the line which is passing from the pole and the center of curvature. You can see this black line which has been drawn over here, and the line is not definite till the sphere. This is going beyond the sphere also. So that means the principal axis, they do not have a particular length defined. They go still infinity. But the only condition is that they need to be passed from pole and the center of curvature together. If any one point has been passed, they cannot be considered as principal axis. Both the points need to be passed to name it as a principal axis. Okay, this is that particular line from where all the calculations will be done. So this line is very important line in drawing the ray diagram. The next point after principal axis is radius of curvature. Radius of curvature. Radius word has come. This is represented by capital R. Radius means the radius of this particular sphere. So radius has been denoted by P and C, the length of the line between P and C. This is known as radius of curvature. I am going to mark it here from P to C. This length, this is known as radius of curvature. The next part is also a very important one, and this is often asked in the examination, the definition of it. Principal focus. Principal focus is that particular point such that, suppose in a concave mirror, and this is a convex mirror. Okay, so concave mirror, this is the back side of it. This is the principal axis, this is pole, this is center of curvature, and this one is a convex mirror. So one by one, let us take it one at a time. So let us suppose in a concave mirror, when the lines are, when the incident rays, these are the rays which are coming from here and they are parallel to the principal axis. So when they hit this particular point, they are going to reflect back, right? So bounce back, that means reflection is going to take place. So when they bounce back, they have two options. Either they can go in this particular direction or they can go in this particular direction also. Where they will move, that depends on the type of the mirror that we are using. Since this is a concave mirror, so this is going to bend the rays inward like this. Okay, and if I make another ray, one more ray from the bottom of the principal axis, and when it reflects, bounces back, this is how it is going to pass. Inward, not outward. The bend will be inward. So this particular point where it strikes, where it passes, that point is known as what? That point is known as focus. Okay, so this point is known as principal focus. And in this particular case, if the rays are coming, so now you can tell they are not going to bend inward, rather they are going to bend outward. Why? Because the nature of the mirror is what? Convex mirror. So they are going to bend the rays outward. Similarly here also. So by no chance these rays are going to meet at the back. Where they are going to meet? They are going to meet somewhere behind the mirror. And this dotted line is telling us what? We have done construction. That means this is the imaginary rays that we have drawn. Actually these rays are not meeting. They are not supposed to meet. But we have made a construction. We have done a construction over here so that these rays meet. So wherever they meet, that particular point is known as principal focus. So in case of concave mirror, if the rays are parallel, if incident rays are parallel to the principal axis, after reflection from the mirror, they actually meet at this point. But in convex mirror, if the rays are parallel and after reflection, they appears to come from, diverge from that particular point. So that particular point is known as what? Principal focus. Okay. Principal focus is generally supposed to be the the center point of P and C. Generally it is found that between P and C, it is the center point is the focus. Fine. So till here we have done this, and the last point that we have is the focal length. Now focal length, since all the points are defined here, if this is the focus, so focal length will be what? Focal length will be the length of the line between P and F. And how it is denoted? This is denoted by small f. So focal length is denoted by small f, length of line between P and F. Please go through the details in the book, go through the definitions which are given in the notes also. Everything is been provided and it is given in the description box, also in the ERP. And if there is any doubt, please write in the comment section. Thank you.